Okay, let's review factoring quadratics. We must know how to factor quadratics before moving into our next lessons of solving quadratics. So let's go through a few examples together. Our first one, we have negative 12x squared plus 16x minus 24. So we always ask, is there a greatest common factor? We do have a greatest common factor here. We can see that 4 divides in each of these terms, but I want to remind everyone that when your leading coefficient is negative, we must also factor out the negative. So I'm going to factor out a negative 4, and we are left with 3x squared minus 4x plus 6. Now let's ask if this quadratic can factor further into some binomials. And so we're going to multiply our new 3 and our new c, and we get 18, and then our new b is negative 4. So if we list the pairs of factors of 18, we have a short list here. So we're asking, can any of these pairs add up to a negative 4? And our answer is no. So whenever we cannot find two factors of our product that add up to our sum, we are finished factoring. So here's the two factors of our original quadratic trinomial. Example number 2, we have a leading coefficient of 1. Let's see if we can factor this into binomials. So 1 times 28, and then our b value is negative 11. Since a is 1, we know this is going to factor quickly. So we are going to factor x squared into x and x. We can factor our 28 value into negative 4 and negative 7. And so we have x minus 4 and x minus 7, or the other way around, and we are finished. Our third example, we're going to have a GCF of 2. When we factor out a 2, we get 2x squared plus 5x plus 3. Now we're going to split our middle term of 5x. The product must be 6 when we split our new b value. So 2 times 3 is the 6. So we can say 2 times 3 is 6, and 2 plus 3 does give us 5. So let's split 5x into 2x plus 3x, and then we have plus 3. If you switched and put the 3x first, the process is the same. Your next line will just look different. So now that we have 4 terms, let's group our 2 binomials. We have 2 binomials. So now we're going to bring out our GCF still, bring it down. Do not forget your GCF of 2. The GCF of this binomial is going to be 2x, and when I divide out 2x from each of these terms, I'm left with x plus 1. Don't forget your operator in between the two binomials. It is a plus, and our GCF for the second binomial is a 3. So we're going to divide out a 3, and we're left with x plus 1. Here's a place we can check ourselves. These have to be the same. If not, we've done something wrong. We're going to bring down our GCF of 2. We have 2x plus 3. That comes from here and here. And then our common binomial of x plus 1. So we have 1, 2, 3 factors of our original quadratic trinomial. Now let's remember our 2 special quadratics. This, if we can identify these as what they are, then we can factor very quickly. So perfect square trinomials, we have a perfect square, our first and last term. The product of the roots doubled does give us that middle term. So the root of 81 is 9. The root of x squared is x. And when we double that, we do get 18x. So when this happens, we can simply write the factors. The binomial factors are the same. So we take the root of our quadratic, we take the sine of the linear, and then we take the root of the c value, and we have two of those, so you can write it x plus 9 quantity squared. Our second perfect square trinomial, we can identify that this is a perfect square trinomial when I take the root of 225, that is 15. When I take the root of x squared, that is x. And if I double this, I do get the 30x. And it is okay if your linear term is subtract. Okay, of course, the perfect squares have to be positive because anything times itself is positive. So we can factor this real quickly. Root sine root quantity squared. The difference of two squares is when we have two perfect squares and we have subtraction that separates these two perfect squares. So we have no linear term. Our b value would be 0. So I'm simply going to set up my two binomials. This is going to be known as as conjugate pairs, where your binomial is the same, except one is plus and one is minus. And this positive and this minus is what creates a linear value of 0, or we have no linear value. Here we have a perfect square, we have no linear value, and we have subtraction. So we are going to take the square root of the quadratic. We're going to take the square root of the c value, and one is positive and one is minus. Okay, so here are the 8 problems that you are to do on your own, and write these on paper. Show your work step by step, and circle your final answer. I'm going to come back and show the work of these, and I'm just going to go through them as quickly as I can. You can check your answers before you submit your work. So pause the video and try these on your own. Number 1, there is no c value. We do have a GCF of x. We factor out the x, and we have x minus 8. This is a linear binomial, so I can't factor it anymore. And these are our two factors. Number 2 is the difference of two squares. So I'm going to set up my conjugate pairs. One is plus, one is minus. I take the square root of the x squared and I factor it. And then the square root of 16 is 4, and we are finished. There is no GCF. Our A value was 1. 1 times -9, and then -8. So we think of the two factors, and it's going to be -9 and 1. And so we have x minus 9 times x plus 1. Number 4 is a perfect square trinomial because I have 4x, the root of 16, the root of x squared. If I double that, I do get that middle term. So we're going to say root sine root quantity squared. Number 5, we do have a GCF because it's a negative, so I'm going to divide out a -1. I'm going to set up my big X graphic organizer. Now I have a 1 times a 20, and my new B value is -12. So I'm going to bring down the negative. Don't forget the negative, just bring that down. And now that our A is 1, we can simply set up x and x. We factored x squared into x and x. And now we're going to factor 20 into -2 and -10. That does gives us a positive 20 and a -12 sum. So -2 minus 10. So you would need to have your negative out front and these two binomials in any order that you wanted to write them. Number 6, we do have a GCF of -3. So I'm going to factor out a -3, and that's going to be plus 2x. And let's Just calculate this right quick, and we get a negative 35. I really didn't need to do brackets right here because my A value is 1, so I don't have to go through the grouping process. Anyway, bring down your negative 3, set up your two binomials. I'm going to have x and x because we factored x squared. And so we have a product of 1 times negative 35, and we have a sum of positive 2. So 7 and negative 5 gives us our product and gives us the right sum. So I'm going to have x plus 7 and x minus 5. Okay, on our last two, we have a GCF. These are all even numbers, so I know at least a 2 can come out, and that gives us 7x squared plus 23x, and then we have plus 18. And now I'm definitely going to use my calculator to help me split the middle term. So here we go. 7 times 18, that's going to give us 126. And then we have a 23 on the bottom. Get my calculator out. And so, just as a reminder, we're going to go to table on our phone. We're going to put in, it prompts us with y equals 126. Click divide, and then your x variable, because we're trying to say what values, what factors of 126 is going to add up to 23. And we're going to scroll down and see, looking for the 23. Okay, 9 times 14, 9 times 14. So we're going to split 23x into plus 9x plus 14x. And now let's group the first two and the last two. Bring down your GCF. We can factor out an x from our first binomial, leaving us with 7x plus 9. Bring down your plus. We can factor out a 2, and we're left with 7x plus 9. So that indicates we are on the right track. Bring down your GCF. We have 2 times x plus 2 times 7x plus 9. On our last one, they're all divisible by 5. So I'm going to factor out a 5. And we're left with 3x squared plus 20x minus 100. Bring down our 5, and we are going to split the 20x. Three times negative 100, negative 300, and we're trying to get 20. So I'm just going to go to my table, and this time we're going to put in, I usually do not put in the negative, just keep that in mind. And so we're looking for a sum of 20, and one of them, it has to be a negative because we have a negative product. So let's scroll down, and 10 and 30. So some of you probably didn't need the calculator, but it is early in the morning on this online learning day. And let's have the 10 be negative. So I'm going to say minus 10x plus 30x. So you can see that still is equivalent to 20x. Okay, now let's go to group, 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 and group. Bring down your 5. And our GCF from our first binomial is simply x, and we have 3x minus 10 plus, don't forget your operator here, and then we can factor out a 10 from these two terms, and we get 3x minus 10. Again, checking ourselves, these are the same. So we have a factor of 5, a factor of x plus 10, and a factor of 3x minus 10. And always, it doesn't matter if you switched the order of your factors. So make sure you finish this out and submit that in Canvas.